In this lecture, we are going to give you more detail about the other procedures of amplitude modulation. Like we are going to discuss about the modulation index, that we have already defined in our previous video. So modulation index is basically the ratio of the amplitude of the modulating signal to the amplitude of the carrier signal. So we are going to give you more details that we have already calculated the amplitude modulator signal AM like this: AC cos omega CT plus mu of AC divided by 2 cos omega C plus omega M, and then plus cos omega C minus omega M. So we have already derived that formula in our previous lecture. So that is the amplitude modulator signal of the amplitude modulations. So if you wanna write in terms of frequency contents, so like the same signal here, so we can see that. So this is omega, and that is the carrier. So you can see the center frequency is, so the center frequency is omega C, and the other two frequencies here are omega C minus omega M, and this one is like omega C plus omega M, and the amplitude of these two portions is that one, so which is mu AC divided by 2, and the amplitude of that carrier is basically AC. So that is the amplitude modulator signal, and this is the representation in terms of the frequency. And if we wanna calculate the bandwidth of the modulator signal, and we know that bandwidth is usually the high frequency minus low frequency. If you look that signal, so you can see that beyond this portion you don't have any signal, and then beyond this portion you don't have any signal over there. So it means that this is your high frequency, and then this is your low frequency. So if you write higher frequency omega M minus low frequency omega C minus omega M, so that is equals to, so this will be cancelled out, that is equals to 2 omega M. So from here you can see that the bandwidth of the modulator signal doesn't depend on the frequency of the carrier signal, it depends only on the frequency of message signal. It depends only on the message signal. So we are going to give a more explanation, or further explanation about the modulation index. So if we wanna write down here, how can we represent the modulator signal? So in the modulator signal, we know that we have a message signal who is something like this. We have a message signal is something like that, and the other way around, we have a carrier signal so here, so this one is basically, so this is the amplitude of the carrier. So this is the amplitude, that was the amplitude of the AM. So it means that this one was AC plus AM, and here, so this is something else as well. So this will be AC minus AM. Similarly here, so you have three terms. So if you add them together, like if you add AC plus AM, so this is the highest amplitude, and AC minus AM is the low value. So if you add them together, so like your addition will give you AC plus AM plus AC minus AM. So you can see this will be cancelled out and the remaining is 2 AC, and the subtraction AC plus AM minus AC plus AM, this will be cancelled out and the remaining is 2 AM. So you can write in the format of E max. So E max is basically equals to AC plus. So you can say, so this one is E max, and then you can say this one is E min, minimum voltage and the maximum voltage. So if you add them together, it will give you 2AM, it will give you 2 AC. So if you subtract them, it will give 2 AM. So it means that you can write the modulation index. 2 AM means you can write AM in this format, like you are subtracting E max minus E min. So if you are subtracting E max EM, it will give you AM. So if you divide by 2, it will give you AM. Like if you divide this 2 AM with 2, so the result will be AM. Similarly, if you subtract them, if you add them together, like E max plus E min, so if you add them together, it will give you 2 AC, and if you divide with 2, then the result will be AC. So that is why you are dividing it with 2. So in this case, your modulation index, you know that your modulation index is AM divided by AC. So what is AM? AM is basically equals to A max minus E min divided by 2, and then E max plus E min divided by 2. The result will be equals to E max minus E min divided by E max plus E min. So these two will be cancelled out. So this is the amplitude, this is the modulation index of the signal. So the modulation index ranges between 0 to 1. So it ranges between, you can see that it ranges between 0 to 1. So that could be its range, but it can have modulation can be less than 1. So modulations can be equals to 1. Modulation index can be equals to bigger than 1. So in this case, if you say that your modulation index is less than 1, so what does that mean? So modulation index is AM divided by AC. So less than 1 means that your AM is less than your AC. AM is less than your AC. So that is this case. Here you can see that your AM is less than AC. So if this is the case, you can say it is under modulation. So you can give the name under modulation. But if your modulation index is equals to 1, so what does that mean? So AM divided by AC, So which results mean that AM is equals to AC. So if AM is equals to AC, so your signal is something like this. So it means that your modulation is critical modulation, and the name of that is critical modulation. The third part is your modulation index is bigger than 1. So what does that mean? AM divided by AC means that AM is bigger than AC. So if this is the case that AM is bigger than AC, means that AM is bigger than AC. So if this is the case, then you can say that your modulation is something like this. So you can see that it is so here, so this is the portion, so which is overlapping, and then you can say it is over modulation, which is the case of crosstalk. So if this is the case, so it means that you cannot transmit your signal very well. So that is not a good modulation. So you are doing over modulation. The second thing is power. Second component is power. So you need to calculate what is the power. So we know that power is basically the square of the RMS value 2 divided by 2. So in our signal we have two things. The first one is the carrier and the second one is the sideband. So it means that the power of the carrier, so if we want to calculate like if you want to write AM, that is the carrier, so is he the amplitude of the carrier, so you can say the AC amplitude of carrier, and mu AC divided by 2, so that is the amplitude of sideband. So what is the power of the carrier? So power of the carrier is AC square divided by 2, and we know the total power will be equals to the power in the carrier plus power in the side bands. So the power of the carrier is equals to power AC square divided by 2, and the power of the side bands, like the power of sideband is equals to, so mu AC divided by 2 whole square and then divided by 2. Similarly, plus mu AC divided by 2 whole square and then divided by 2, because you have two sidebands, this one and that one. So the total power, if you add them together, like AC square divided by 2 plus mu square AC square divided by 4, and then into again, or you can write 1 over 2, you can take common 1 over 2, so you can take common 1 over 2 plus mu square AC square by 4, and then so 1 over 2 here as well, AC square here, here is as well AC square by 2, you can take common, so 1 plus mu square by 4 plus mu square by 4, and then the remaining is AC square by 2, and then 1 plus, if I add them together, result is mu square by 2. So this is the power of the carrier, so you can write PC into 1 plus mu square by 2. So that is the total power. So that is the total power. The second component you want to calculate is the efficiency. Efficiency is basically the eta, so which is basically the ratio of the useful power to the total power. Ratio of useful power divided by the total power. Useful power means the power in the sideband, so that power in the sideband is basically equals to that one. So this is the power in the sidebands. So AC square divided by 2, and then mu square by 4 plus mu square by 4, and then divided by the total power. And we know that the total power is that one is C square by 2, and then 1 plus mu square by 2. So this is cancelled out. The remaining is that one is basically mu square by 2, and then 1 plus mu square by 2. So if you take 2 as LCM, so the other one is 2 plus mu square and then divided by 2. So these two can be cancelled out with that 2. So the efficiency, you can write the efficiency is equals to mu square divided by 2 plus mu square. The other component is the redundancy, so which is equals to 1 minus efficiency. So if you use that formula here, so 1 minus mu square divided by 2 plus mu square, so which is equals to 2 plus mu square minus mu square divided by 2 plus mu square. So that is cancelled out. The remaining is 2 divided by 2 plus mu square. The other one is that you write in terms of currents, like currents means total currents and the current in the carrier. So you know that PT is basically equals to PC, so 1 plus PT is equals to PC 1 plus mu square by 2. So you know that power is basically the formula of current multiplied by resistance. So IR basically IR is basically I square R. So I square R is basically the resistance of the radiation of antenna. So you can write here, so that is IT square multiplied by R is equals to IC square multiplied by again R, and then 1 plus mu square divided by 2, and then so R will be cancelled out. So IT is equals to IC and the under root 1 plus mu square divided by 2. So that is the current, that is the total current of the system. So I hope that you have understand amplitude modulation in full detail with the different parameters, giving like efficiency, power, redundancy, and the currents. So if you have any question or recommendations, you are most welcome. You can write your comments and suggestions in the comment box. So and also you can like and subscribe our videos so that you can see our next incoming lectures. Thank you for watching the video.